Opening start.spring.io in a web browser, I will configure a Spring Boot project and download it. As you see on the top, this will be a Maven-based project. I will configure group, artifact, and description for this project. The idea here is to have a project template locally available, which we can use to spin out multiple projects without having to connect to internet every time. The objective of this configuration is to develop a web-based project. For this, I will change the packaging to var. Another thing we need to do is to include web dependency. Let me download and save it locally. Now, I will extract the downloaded zip file and copy the contents of this folder into our checked out repository folder. I will use Spring Toolsuite to develop this project. Now switching to STS, I can easily import this as an existing Maven project. All I have to do is to navigate to the checked out folder and the existing form will be automatically picked up. The IDE also recognizes Git integration in this project automatically. If you observe closely, each of the file will be identified whether it is committed or not. Spring Boot template provides us with some of the classes which is pre-built. In this case, I want to rename and change it a little bit. The point to note here is the integration capabilities of our development tool with the supporting technologies. In this case, STS seamlessly integrates with Git and Maven. Now, we can start Git actions from here itself. I will ignore some files and this will be copied into .git ignore file. Now going into team menu, I can add the files into index, that is git index, and I can also execute all the source code management actions from here. Using the commit dialog, I can commit the project into my local master. Let us see how it commits and where it commits actually. I will just use the commit button for this instance. Now, switching to terminal, if we examine the git status, local master is ahead of the remote master by one commit. What it means is that our local master is the most recent one, so the changes needs to be pushed upstream. We can do this by team and pushing it to upstream. Using the push upstream, the changes will be promoted back to the remote master. Now, if we switch back to terminal and check the git status, we can see that the working copy and the remote copy are same. Okay, let's go back to development. So now the objective here is to develop a simple REST service. For this, I will create a Java class and use Spring's REST controller annotation to change it into a simple Spring web service. I am using Eclipse shortcut. The next step is to build an API which will generate a dynamic content. In this case, we will be generating new date and time. I will convert the date time into a HTML formatted string. Now, the next step is to map this API to a URL. For that, I'm using request mapping, which is still supported in this version of Spring. I will use /time. Now let us run the project as a Spring Boot application. We can also run it as a Java application. This application runs with the embedded Tomcat container. If we scroll down, we can see that it is listening on port 8080. Let us test it from the browser. Navigating to 8080, if we use /time URL, we see the date and time component, and it changes over multiple requests. Okay, let me stop it. And now let us go back to our git commit cycle. So the first step is to add to index and then to commit and push it back to upstream. As we did earlier, we have to use the git commit dialog box. We can also see here that our IDE has picked up git global configuration. The last step is to push the changes back to remote.